Lesson 13, Combinations of Transformations. Now that we know how to translate, stretch, and combine functions, we can combine these steps to create more advanced transformations. So now that we know how to translate, stretch, and combine functions, we can combine all the steps to create more advanced transformations. All we are really doing is putting together the concepts we learned in the previous 3 lessons. So all we're doing is putting together everything we learned in the past 3 lessons. Remember that a function must be written in standard form before we can describe any transformations. A function must be in standard form before we can describe any transformations. Let's go through what each of the parameters means once again. We have y equals a times f of k times x minus d plus c. The variable a stretches or compresses a function vertically. If a is negative, a reflection over the x-axis occurs. So that's the variable a. The variable k stretches or compresses a function horizontally. If k is negative, a reflection over the y-axis occurs. So reviewing, the variable a stretches or compresses a function vertically. If a is negative, a reflection over the x-axis occurs. The variable k stretches or compresses a function horizontally. If k is negative, a reflection over the y-axis occurs. The variable d translates a function left or right. So the variable d translates the function left or right. The variable c translates a function up or down. So the variable c only translates the function up or down. Before we complete any exercises, it is important to note that reflections, stretches, and compressions must be done before horizontal and vertical translations. So it's important to know that reflections, stretches, and compressions must be done before horizontal and vertical translations. This is because order of operations can be applied to a function and how dependent variables are found. So this is because we have to apply order of operations to a function and do so when we're in the way we determine dependent variables. So going back to the function, we see that all reflections, stretches, and compressions are multiplications and divisions. So A is a stretch or compression and a reflection. K is a stretch or compression and a reflection. And these are multiplications or divisions. D is a translation left or right, and that is a subtraction or addition. C is a translation up or down, and that is an addition or subtraction. So D and C are additions and subtractions, and they have to be applied after multiplications and divisions. So A and K have to be applied first, along with any reflections, any negatives on the A and any negatives on the K. Those have to all be applied first, and then D and C are applied. And then additions and subtractions are applied. First, multiplications and divisions are completed. So first we complete multiplications and divisions. Stretches and compressions all multiply either the dependent variables or independent variables by a particular factor. So first we complete all multiplications and divisions. Stretches and compressions all multiply either the dependent variables or independent variables by a particular factor. Reflections are simply multiplications by -1, which is why a -a or a -k denotes a reflection. So reflections are simply multiplications by -1. So when this is negative or this is negative we have a reflection, which is why a negative a or a negative k denotes a reflection. Addition and subtraction is done afterwards. So vertical and horizontal translations, which are simply additions or subtractions, are done at the end. So we do these at the end, D and C, because they're vertical and horizontal translations, which are simply additions or subtractions. So we do them at the end. Let's go through an example that combines different transformations. Describe the transformations that must be done to the base function f of x equals x squared to reach the transform function g of x. In addition, write the equation of the new function and graph it. So f of x equals x squared. The transform function is g of x equals 1/2 times f of 1/2 times x minus 2, all of that plus 2. So let's write the equation of the new equation first. First we write the equation of the new equation. Of the new function, sorry. Let's write the equation of the new function first. So to get the new function, we apply the set of transformations on the function f of x. We get 1/2. We apply a 1/2 times 1/2. We apply k 1/2 times x minus 2. We apply d. And we square all of that, because f of x equals x squared. And then we apply c plus c plus 2. Now let's describe all transformations. The function is compressed vertically by a factor of 1/2. That's a. A equals 1/2, so the function is compressed vertically by a factor of 1/2. The function is stretched horizontally by a factor of 2. So that's k. Because the function is stretched horizontally by a factor of 2, because 1/k, the reciprocal of this, is what we stretch or compress the function horizontally by. So the reciprocal is 2. So we stretch the function horizontally by 2. So the function is stretched horizontally by a factor of 2 because the reciprocal of k is 2. So 1/k is equal to 2. So the function is stretched horizontally by a factor of 2. The function is translated 2 units right because d is -2. When d is -2, the function is translated 2 units right. If d were +2, the function would be translated 2 units left. So the function is translated 2 units right because d is -2. The function is translated 2 units up because c is +2. So the function is translated 2 units up because c is +2. Now let's graph the transform function. We have f of x equals x squared. And we simply graph the key points 0, 0, 1, 1, 2, 4, 0, 0, -1, 1, -2, 4, and we simply connect the dots. Now to graph the new function, the transform function, we take one point, we take every point, and we apply these transformations on every point. So let's do that for one point. And we just do that for all key points, and we connect the dots. And that gives us the transform function. So let's do that for one point. For the point 1, 1. The function is compressed vertically by a factor of 1/2. So because the function is compressed vertically by a factor of 1/2, the new point is 1, 1/2. The function is stretched horizontally by a factor of 2. The new point will be 2 1/2. So remember, the function is compressed vertically by a factor of 1/2. We take the y coordinate of 1 and we compress it by 1/2. So we get 1/2. The function is stretched horizontally by a factor of 2. Means we take the x coordinate 1 and we multiply it by 2. So we get 2 1/2. The function is translated 2 units right. So we get 4 1/2. We take 2 and we add 2 units right. So 2 plus 2 is 4. So we get 4 1/2. The function is translated 2 units up. So we take the y coordinate, which is 1/2, and we add 2. So we get 2.5. So the new point is 4 2.5. And we plot the point. We do this for all points and then we connect the dots. The red parabola represents the transformed function g of x. The blue parabola, the blue one represents the original function f of x. As you can see, using combinations of transformations, we can change the position, shape, and orientation of a function. So using combination of transformations, we can change the position, shape, and orientation of a function. That's all you need to know to transform functions. Just remember, reflections, compressions, and stretches must be done before translations. Remember, reflections, compressions, and stretches must be done before translations. And that's all for lesson 13, combinations of transformations. Stay tuned for lesson 14, inverse of a function. Also, if you like this lesson, be sure to like and subscribe, and hit the like and subscribe, and give a positive comment. Thank you.